In this last video, I want to give you a chance to copy down some of the definitions that I mentioned in the previous videos and copy them down in your notebooks. I'm hoping that you have been copying down the examples in the other videos into your notebooks. You know, you can stop, you can pause, and you can replay these over and over until you have as many notes from them that you want. So the first two, of course, that we talked about is that a ratio is a comparison of two numbers, and a proportion is two or more ratios that are equal to each other. And so working on the cross products, we have seen that those are proportions. So now we're going to look at real life examples of how we apply proportions. And one of the first ones is scale drawing. So scale drawing or scale models or the scale of a drawing has to do with the fact that when we recreate real life objects and in terms of like images or models, that we actually keep the dimensionality. We do it proportionately. So there is this scale that it shrinks down so that it retains its shape and image. That's why you can look at that photograph, this photograph here of the trees, and they still look like trees, even though this image is probably about, a couple of centimeters tall on your screen. An example of an application of scale is this. I'll read you this example. It says the ship model kits sold at a hobby store have a scale of 1 foot to 600 feet. Remember that the colon is the ratio symbol. A completed model of the Queen Elizabeth II is 1.6 feet long. Now, you're probably too young to remember the Queen Elizabeth II, but probably 50 years ago, it was one of the most famous cruise ships in the world, and it was very large. There was obviously there was a Queen Elizabeth I, and there was a Queen Elizabeth II, and then there was a Queen Mary. It was a whole shipping line of very elegant cruise ships. So anyway, we're going to find we want to find the approximate actual length of the Queen Elizabeth II, knowing that we have a model of the Queen Elizabeth that's 1.6 feet long. So the model is drawn or built with the scale of 1 feet to 600 feet. So that means that if I set up two ratios, one, the scale of 1 foot in the model to 600 feet in real life on the ship, equal to the 1.6. So notice in the numerator of the other fraction, I also have model measurements. And so I have the model of the length of I'm tongue-tied. The 1.6 feet is the length of the model of the Queen E. So what we're looking for is the actual feet. So we perform a cross product, and we're going to multiply x times the 1 feet and 600 feet across to the 1.6 feet. And when we do that, we find out that the ship model is 960 feet long. I know this is just one example of using scale, but you're going to have an opportunity tomorrow in class to work on some scale and some cross products in other examples. Thank you.